Here we are going to move on from ions to look at ionic bonds and ionic compounds. In this lecture, be able to identify ionic compound, ionic bonds, the chemical formula, which you will definitely be using more of later, the formula unit, and the coordination number, which you will need to know what it is, but not how it works. Write the chemical formulas of ionic compounds. Relate chemical formulas to coordination numbers, and that's only somewhat, really. Construct and revise an explanation for the outcome of a simple chemical reaction based on the outermost electron states of atoms, remember, valence electrons, trends in the periodic table, remember, valence electrons, and knowledge of chemical properties, namely, valence electrons. Plan and conduct an investigation to gather evidence to compare the structure of substances at the bulk scale to infer the strength of electrical forces between particles. That's a more complicated way of saying understand that ionic bonds are electrostatic forces. And ionic compounds are anything that are made of cations and anions. So here we have sodium chloride, a classic ionic compound. It's made of sodium atoms, specifically sodium cations, and chlorine atoms, specifically chloride anions. Remember, the total charge of an ionic compound is going to be 0. And ionic bonds are these electrostatic forces holding ions together. What holds salt together? Ionic bonds, which is the attraction between positive and negative ions. When ionic compounds are formed, it is often during these very explosive reactions. And this is because the loss and gain of electrons is very highly energetic. Here we have the reaction between aluminum and bromine. So aluminum plus bromine is going to make AlBr3. We're going to see exactly what that is in a few, but the aluminum ion is going to lose 3 electrons, and each bromine atom is going to gain 1 electron to become a bromide ion, making that AlBr3. And that will be highly energetic, giving off sparks. And we're not going to do this in class because, I like to keep our classroom. The chemical formulas are a way of writing the relative numbers of each element in a substance. So that is going to be something like NaCl, so sodium chloride, or CuCl2, which is this cupric chloride. So cupric just means there is a +2 charge on the copper and a -1 on the Cl. And then Fe2O3, well, that's just rust. And we're going to look at that one. It's a little more complicated, but that's going to be iron and iron oxide, a specific type of iron oxide. And that's a chemical formula. The formula unit is going to be your whole number ratio of ions in an ionic compound. So this iron 3 chloride has 3 chlorides for each iron because the iron cation has a +3. Remember, the total charge is equal to 0. Now let's look at some properties of ionic compounds. First off, crystals. A crystal has a repeating 3-dimensional structure, and this structure is very stable, so ionic compounds have a very high melting point. Often, crystals can dissolve in water. Now, these crystals clearly cannot, but if you think about sodium crystals or cupric chloride crystals or iron chloride crystals, they dissolve very readily in water. Now, the coordination number is another property of a crystal, and that's how many ions of opposite charge surround an ion. So your example here would be your sodium chloride. It's your basic cubic structure, so on each side of the sodium ion is a chloride ion. So there are 6 different sides in space for this, and that is going to make 6 different chloride ions for each sodium ion around it. Likewise, each chloride ion is going to be surrounded by 6 sodium ions, each one for each surface. And if you start making this repeating cubic structure, you're going to see how this pans out. On the other hand, cesium chloride has 8 different chlorides for each cesium, giving cesium a coordination number of 8. Now, in any exams or quizzes or something, we're probably just going to stick with the if it has this many, what is its coordination number? Or looking at a crystal, what is its coordination number? You see how you can go much more in depth here, but we are not going to get super in depth with coordination numbers. What is also interesting about ions is if you put ions in water, that water becomes highly conductive. This allows water to conduct a charge, and also melted ionic compounds will conduct a charge. All those positives and negatives floating around allow for some really good conductivity. It also means that these can be separated through electrolysis. Now, in electrolysis, you may have seen the separating hydrogen and oxygen, and they added a little bit of sodium bicarbonate. And you're like, well, why did they add sodium chloride? And that's simple. If you add sodium chloride to water and separate it through electrolysis, you don't end up getting oxygen, you end up getting chlorine gas. And as anyone who likes to keep their airways intact can tell you, that's a very bad idea.